everyone, welcome to today's topic. Today we're talking about nets of shapes. So thinking back to what we did just before this, we were talking about prisms, right? Remember, prisms were boxes, rectangular and triangular prisms. We talked about pyramids as well. So today, what we're going to do to those prisms, those 3D shapes, we're going to unfold them, open them up, right? Picture yourself opening up a cardboard box. When you open it up and flatten it out, it forms what is called a net, one of these. That is that box basically flattened out. And so today we're talking all about nets, the different parts of a net, why we use it, and how it's going to lead into a future topic. So it's just a basic introduction today. So if you have your notes printed out, ready to follow along, here we go. Let's start. The objective is to know what a net is and its parts. So this would be more of a definition objective, vocabulary words that you just need to know. You also need to know the terms surface area and faces. So vocabulary words. But we will apply all of that to actually calculate. So we're going to apply the area of the shapes formulas. We're going to apply that to the nets. So remember, thinking back to area of shapes, this is back when we were just doing rectangles and triangles. Each of those had their area formulas, right? Area of a rectangle is base times height. Area of a triangle is base times height divided by 2. Rectangles and triangles are what we're going to see the most commonly in nets. Rarely are we going to see circles or half circles or trapezoids. So basically rectangles and triangles. So that's good news because those are basic formulas. These are our 3 objectives. Know some definitions and apply some formulas. If you can meet all these objectives, if at the end of the lesson you can say yes, yes, yes to all 3, that means you know what today's topic basically was about and you've met the objective. Let's do our vocabulary first. Okay, a net. A net is a 2-dimensional pattern of a 3D shape. It can be folded to make a model of a solid shape. So that sentence refers to what's going on right here in this picture. You see this picture of a net and they're folding it back up. You fold along the lines. Wherever there's a line, that's where you make a fold. Okay, because you might be doing this later today, making your own box. Fold along the lines and turn it into a box. So the net is 2D, but when you fold, it turns into a 3D shape. All right, that's one way to do it. Now you could also work backwards, go from the box and turn it into the net. Okay, so that's here. You can cut apart a 3D box to make it into a net. So up here, that's this picture. Taking a 3D box, cutting it apart along those lines, and turning it into a 2D net. So you can go either way, vice versa. 3D to 2D or 2D to 3D. Next definition is of a face. What is a face? It's not our face, right? This is a face on a shape. It is a face is basically each side of a shape. The sides of a shape. Look at this picture and look at what they've got as the face. Face, face, face. Those are the faces of that box. Now, if you can look through this box and know that there are some faces on the other sides that are not really pictured based on how it is. So can you visualize and imagine how many total faces this cube has? Well, I see 3. So we would have a top and a bottom that's not pictured, but there would be a bottom. There would be a front and a back and a left and a right. So that is a total of 6 faces. That's a good number to remember. Boxes and cubes have 6 faces. Now cubes have every single face is the same. Rectangular boxes, they have their pairs. What about this pyramid right here? How many faces do you think are on this pyramid? Each side is a face. So this right here, that's a face. That's a face. Obviously, there'd be a face at the bottom, right? That it's sitting on. And I guess there'd be two in the back. One right there and one right there that we can't picture, but if we kind of try to see through. So this pyramid would have a total of 1, 2, 3, 4, 5. 5 faces. So this is just a little practice to get y'all to visualize. The sides that are not shown, you still need to be able to imagine what those would be. It's a lot of visualizing when it gets to this. All right, well, that's what faces are. One thing that faces are not these corners and edges. Those are the corners, the points. Those have different names that you might learn later in math. Those are not the faces. The faces are the flat sides of the shape. Faces are also not, they are not the lines. Those are called edges, and those are completely different. So again, that's me going a little further than necessary maybe, but just to emphasize the point that faces are the flat sides of the shape. Okay, moving on. I feel like I've said faces enough. Surface area. Surface area is the area of the outside of a shape. Okay? The best way I like to describe surface area is imagine you have a gift that you're trying to wrap, and this gift is one of those good ones that's a nice perfect shape. It's shaped like a box, so it's really easy to wrap, right? Boxes are always easy to wrap. If I ever have like an odd shaped object, like a candle or something, what I do is just, most of it, we just dump it in a gift bag, right? And put a bunch of tissue paper that sticks out and makes it look pretty. And so that's what we do with the odd shaped objects. Put it in a gift bag. But that's not what we're talking about here. Imagine a perfectly shaped box and we just wrap it up, right? We put wrapping paper all on the outside. We measure out wrapping paper and we tape it nice and neat, put a little bow. There's our gift. That describes surface area because that wrapping paper is going on the outside of the box. It's completely covering the outside only. So when you think of surface area, think of wrapping a box. Surface area is the outside. Can you recall what was the inside? This was a word that we talked about last week. What is the area of the inside of a shape, of a 3D shape? That was volume. The volume was the inside. Surface area is the outside of a shape. All right, so I hope that kind of sticks in your head. Now we're going to watch a video that just shows you a little 3D animation of nets turning into boxes. So you don't have to write anything down, you're just watching the video. Okay, so here we've got a cube, which we're going to unfold, and that turns into a net. So net of a cube. A cube is a three-dimensional shape, but when you unfold it, it has a two-dimensional net, and there are 6 square faces to this cube. 1, 2, 3, 4, 5, and 6. Those are the 6 faces, the flat sides, and so this is a two-dimensional net. Let's see if this net forms a cube. So you'd have to fold it up, fold along the lines. Yes, it closes up, it closes into a box, perfect, so that forms a cube. What about this configuration? Does this form a cube? This kind of net? Only way to see is if you fold it up, fold, fold, fold. There you go, it turns into a cube, so that does work. What about this one? It looks a little funky, but you fold it up. Ah, that one doesn't work because it overlaps right there, and there's an open spot that was not closed. So what we've learned is that these 3 nets can be folded into cubes, right? Those were all successful. But there was this one net that did not work. It did not close up perfectly. So that is just a little 3D animation of how you take a net, fold along the lines, turn into cubes. Some nets work, some do not. You will not have to worry about the ones that don't work. Mostly we're going to just find work with the basic ones. And we're back, moving on in our notes. So what are we going to use nets for? We use nets to find the area of the faces. Now I guess we could find them just by looking at the 3D shape, but that's not always very easy to do. So what we do is we unfold it, right? Open it up, flatten it out. Here's our net, and we can find the area of the faces. Area of the faces being all of these sides. So two things we're going to do. First, we fill in all the missing lengths if possible. All right, there's a lot of sides here that don't have numbers, but we can fill them up, and you need to practice this. Well, what would this side be? Well, that would be the same as that 6. So on your piece of paper, fill in all of these sides. So that would be 6 right there. What about that? That would be the 3, and I get that from that 3. What else do we need? Everything that matches with that 6 would be 6. That would be a 3 right there, and what would this be? So I'm assuming this would be the 2. All right, let's try this out. Now let's find the area of each face. So that face right there. That is a rectangle. Area of a rectangle is base times height. So 2. Oh yes, so they're telling us there's a 2 right there and a 2 right there. So yes, I was right. 2 times 3 is 6. So that face has an area of 6. Now, here's a trick, guys. You don't have to find every individual. Usually there's an opposing side that's exactly the same, right? You see how that one matches this? So this would also be 6, right? Because that would be its matching side on the box. You see what I mean? What I mean is this. This bottom right here that would have an area of 6 would match the top that also would be the exact same thing. So that's what I'm talking about when I say the opposing side. All right, let's find this area right here. So this would be base times height. 3 times 6 is 18. So there we go. We have that one. Its opposing side would be right here, or its matching side right here. That would be 18 as well. Okay, what else do we need? We need this side, or this face. That's going to be another rectangle, so base times height, 6 times 2, which is 12. There we go. And that would match, obviously, this side right here. Okay. All right, we've got all the sides. And this is how you use the nets. Next week, or not next week, in a couple of days coming up, we're going to actually do something with these numbers, the 6, 12, 18. We're going to do something with all of that and find surface area. But for today, we're just finding the individual pieces of the net and leaving it at that. So we've found the missing lengths and we found the area of each face. We're done. Let's keep practicing. All right, another box that has been unfolded and turned into a net. And we need to find, first, let's label the missing lengths. If that is 5 right there, this would also be 5. So 5, I'm just labeling everything. That way it's clear. Well, if that is 3 right here, well, this would also be 3, 3. Let's see. And these are going to be, so that's a 3. This would be 3 right here. If we're unsure, we can always refer back to the 3D shape. All right, so this face is going to be 5 times 4, which is 20. We find its matching side. That's going to be, Okay, well, let's do the ones that are obvious and that we know. 3 times, what's on the side of the 3? It's a 5. This would be, hang on, this is a little difficult to visualize. 3 times 4, this would be the 4. This one's going to be 12, and this one's going to be 12 right here as well, because that would be 4. Here we've got 3 times 5, which is 15. We need to have 2 sides of 15 and 2 sides of the 20. I do admit, this one maybe not the greatest example, the way the numbers were set, but it does help at least that we have this 3D shape. So you can refer back to this to make sure we've done this right. I'll have better examples next time, don't worry. All right, so that side would be a 15, right? Wouldn't there be 2 15s because the top and the bottom would be 15? That's one way to look at it. Now this side face right here, the right side of the box, that would be 3 times 4, which is 12. And wouldn't it make sense that there'd be 2 of those, the other side? So we have 2 12s, we have 2 15s, and let's do a different color for the front. The front right here, that would be 5 times the height, which is 4, and so the front of the box is 20. And so you know that the matching side, the back, would also be 20. So there, we've got the pieces. I was just trying to, clean it up because it wasn't so obvious what is what. Your nets will have more numbers on them than this usually. Okay, and we leave it at this because we found all of the different faces. We found the area of each individual face. We're not going to do anything else as of today. All right. Okay, we've got a triangular prism this time that we're going to unfold, open it up, right? It turns into a net of a triangular prism. This right here, these triangle parts, front and back, that's right here. If we want to color code. And I could color code the rectangular faces. That would be these, right? Oops, I can't color inside the line. And then the base, what we can't see in this picture, right? That base is this right there. Okay, so let's find the area of the individual faces. So triangle formula is base times height divided by 2. We have a dotted line height. Well, what is the base? That would be that 12. So 8 times 12 divided by 2. 8 times 12 is 96. 96 divided by 2 is 48. So the area of this triangular face right here is 48. Good news is once you find one of them, you don't have to find the other one. It just doubles up, right? Because it's the exact matching side. So we have 48 right there. What about these rectangles? We've got 10 and 14, base times height, that's 140. Also 140 right here. And this middle piece is a little different. We've got 12 as the base and 14 right here is the height. So we have 12 and 14, so it's 12 times 14, which is 12 times 14 is, give me 1 second, is 168. There you go. So we found every individual face. 1, 2, 3, 4, 5 total faces, and we found them. 48 and 48, 140, 140, and 168. And that's where we leave off. We're not doing anything more. Last one. All right. Okay, save this one for last because it takes a little bit more work. Let's see if you can label, unfold this. Oops. Unfold. Unfold the prism. Turn it into a net. And at least let's label the sides correctly. This 4 right here represents the height right there. So we need to label the 4 right there. The 5 is a slanted line. So we've got 4 and 5. The length is 12. So every length we can label as 12. And every width is 6. There you go. We've got good numbers for everything. From here, you should be able to find the area of every single face. Okay, and so these were my answers. I got 72 for these 3 rectangular sides, 12 each for the triangles. So check your work with that. All right, your homework tonight. As an activity, you're going to find the area. You have in your notes this net. You're first going to find the area of each of these faces. That part is more important. And then you can cut this net out and fold it up. Remember to fold along the lines. You've seen in the animation how to fold. And then to close your box, you might just need to put a piece of tape. Color. I would color first before you cut and fold. Color, and then make it be a little creative, you know, put whatever designs you want. Some people have turned this in the past into a Rubik's Cube, though it's a rectangular box. You can do any design, you can do solid color for each side, doesn't matter, it's up to you. Close it up, and I would like you to submit a picture of your box as a way to check that you've done this assignment. All right, that wraps up this topic. Good luck with your activity. See y'all next time.